This conference will now be recorded. This conference will now be recorded.
Okay, so we're looking at the part 6C of module 2, which is switching and virtual LANs. Okay, switching and virtual LANs. So remember when we were looking at the OSI layer, we looked at the 7 layers of the OSI layer, from the application, presentation, session, transport, network, data link, and the physical layer. And I remember when we pointed out that the network is at layer 3. That's where you have IP. That's where you have routing. So anytime we discuss routing, it happens at layer 3. It works with IP addressing, it works with packets at layer 3. Now, when we talk of switching, switching is at layer 2. So anywhere you hear switching, switch, VLANs, all operate at layer 2. So layer 2 switching is a process of using hardware addresses of devices on a LAN to segment a network. So each device is, as I explained earlier, that they have what we call a built-in address, a hardware address called MAC address, media access control. So those addresses are what signifies or what a switch or a device communicates with at layer 2. So switch is a layer 2 device, router is a layer 3 device. And remember when we're talking about frames, so at switching level, at layer 2 level, what is being exchanged at layer 2 is frames. So there are a lot of story here. So switch functions. So what are the functions of a switch? Remember, we're looking at introduction to routing and switching. So we've looked at routing. Now we're looking at switching. Now, what are the functions of a switch? There are 3 major functions. There's address learning, there's filter and forward and filter decisions, and there's loop avoidance. So these are the 3 major functions that switches perform at layer 2. Now, the first is address learning. Now, if you remember when we're looking at ARP, Address Resolution Protocol, I made mention that Address Resolution Protocol is a protocol that maps MAC addresses to IP addresses. So it's able to statically or dynamically map that the hardware addresses that a device has with the logical address or the IP address that's been assigned to that device. That is what we call a map cache. Again, an app cache, ARP cache. So it's more like that database that has that mapping. Yes. So for a switch to be intelligent enough to know who is connected to who, it needs to be able to learn addresses. It needs to know who is connected. Because a switch, if you bring a dummy switch or a switch that has not been connected to the network and you plug it to the network and you plug devices, the switch needs to know that on port A is where I have PC A, on port B is where I have printer B, on port C is where I have laptop. So he needs to be able to know who and who is connected to me, so that when he gets an information, he can forward it to the appropriate quarters. So that is what a switch. So it needs to learn those addresses, and what it learns it or where it populates it is what we call the MAC address table, the MAC table, the MAC database. So that is where it pulls in all the addresses that it has learned. All the addresses it learns, it puts it in the MAC address table, because in that MAC address table is where you have the mapping of ports and IP address. So let me give an example. So if you look at this switch here is empty because the MAC address table or MAC forward filter table is empty. It doesn't know that port A is connected to E0/0, port host B is connected to 0/1, port C is connected to 0/2, port host D is connected to 0/3. It doesn't know. So what it needs to learn, it needs to be able to learn the MAC address of everybody. So how does it learn MAC address? Now this is what it does. Now if host A has a message for host B, it sends it to the switch forwards it on every port. So everybody gets the message, and the person that message is meant for will reply. So what a switch does at the initial stage, it floods the message on all the ports. Then the person who replies, he gets the MAC address of that person. He gets the MAC address of that person and populates his MAC address table. So as you can see here, from step 1, he sends a message. Step 2 is able to record that, okay, this is the MAC address of the device connected to me. Then when I send it to 3, everybody gets it. Then 4, I'll be able to record the MAC address of the person that responded. So with this, the switch populates its MAC address table. So now the other function we're looking at here is forward and filter decision. Forward and filter decision. Now the forward and filter, yes. So when a frame arrives at a switch interface, the destination hardware address is compared to the forward and filter MAC address table, and the switch makes a forward or filter decision. So what it means here is that when this MAC address table is populated, is able to make intelligent decisions. So if you have a message for host C, he knows that the person who is connected to E0/2 is host C. It will forward it on host C and not forward it on every port. Reason why is because it has in its cache, in the table, the MAC address of host C. That's what forward and filter decision means. That's what a switch does. Another, so this is a good example. So you have 0/3, 0/4, 0/5, 0/6. It populates the MAC address table with their MAC address. Then when you do show MAC address table, it will tell you the MAC address of every device connected to it. So that is the second function of a switch. Now the third function of a switch at layer 2 is loop avoidance. Loop avoidance. Loop avoidance. Now when you have 2 switches here, let me use this as a scenario here. So you have switch A and you have switch B. Remember that the way a switch learns MAC address, that first of all, it will flood it on every interface and wait for the person to reply. So when this server sends a message, it gets to this switch will forward it to everybody. It will get to this switch will forward it to everybody. This switch getting it will forward to everybody. That's how you now have a loop, because everybody is flooding their each port so that they can find the MAC address of the connected host. So that's where and switching also to ensure that there is avoidance of loops even in the network. So this is also more explanation to the loop avoidance. Now, one of the protocol that a switch uses to avoid loop is STP, Spanning Tree Protocol. Spanning Tree Protocol is a protocol that switches use. That switch is used to stop spanning tree, so as to stop network loops, because it's a protocol that monitors. It monitors to see if another switch sends it a message. So how do I know that a switch is connected to me? Why? Is because there is a particular message that switch will be sending. So I need a protocol who will pay attention and be able to make intelligent decisions as to when he wants to flood uh, the request for IP for addresses. Again, is able to know that, okay, I am connected to a switch on this port, because when that switch is forwarding it, it knows the type of request. They call it BPDU. Again, it knows the particular type of message that is coming from a fellow switch. So when it knows that this port is connected to a fellow switch, it will block that port. That's what spanning tree does. And these are the 5 states of spanning tree. So it will first of all block the port. It will listen for for connections. It will learn about addresses, it will forward, and it can also disable the port. The whole idea of STP or spanning tree protocol is just to avoid loop on a network. So switches populate the MAC address table in learning and forward. So switch ports are usually in either blocking or forwarding states. So these are the switch ports, STP port states. You also have convergence. Convergence is when each of the ports or the ports of a switch are known. It's more like a network is full. When you say a network is fully converged, means that each devices within the network has an idea who and who is connected to it. So when you say STP convergence, it means that STP working in a switch or running in a switch is able to know all the ports connecting to other switches, or all the ports other switches are connected to it. Then you will say you have convergence, because there is more like no surprises. You know the topology, you know which is connected to which. You have an idea of that topology. So that is what we call STP convergence. So another concept which we've explained earlier and is of great also repeat is VLANs, virtual LANs. We've talked about virtual LANs. And I remember at the beginning class when we were talking about VLANs. So we said it is a LAN, but the only difference is that it is virtual. It is virtual. Means you can't see it. You don't have to be physically together. It means that you can span this LAN across different buildings, all virtually. So a VLAN is a logical grouping of network users and resources connected to administratively defined ports on the switch. So that's what a VLAN is. You get. So you create VLAN. So you can have a VLAN for sales. You can have a VLAN for engineering, a VLAN for HR, a VLAN for security, a VLAN for any department in the organization. And as it is in many offices, you can have staffs on multiple floors belonging to the same department. You can have staff even in different parts of the world belonging to the same department, or in different parts of the country belonging to the same department. So what you do is to create a VLAN so that all of them will, irrespective of their diverse geographical location, they will be as though they are in the same LAN or in the same network. So that is what a VLAN is. Now, these VLANs can be static. It can also be configured dynamically. So there's always what we call a VLAN tag or a VLAN ID. So whenever you are configuring VLANs, you need to give it a name. So just the way you have sales, you have engineering. So, but in VLAN, you give it a number, then you can now name it maybe with the description. So you say VLAN 10, VLAN 1, VLAN 20, VLAN 30, VLAN 50. So all of those things are like tags to be able to tag each of the traffic. So so in a switch, you're able to have multiple VLANs. So I can logically create multiple VLANs on a switch, and each person within the same VLAN will talk to each other as though they are physically in the same network, while people on different VLANs will not be able to communicate with each other because they are on different VLANs, except I introduce a router that will do what we call inter-VLAN routing, which means one VLAN communicating with another VLAN. So these VLANs can be statically assigned, can also be dynamic. Now, identifying VLANs. A switch port can belong to only one VLAN if it is an access port, or all VLANs if it is a trunk port. Now, one illustration I like using for VLANs, or when it comes to access port and trunk ports, is your electrical fittings. Now, if you have some electrical fittings, you know that there are some trunk that you will see different wires going through that trunk, different wires. Now, that is a trunk port. So you have multiple VLANs going through that one trunk. But a socket, you only have one wire that is powering that socket on the wall. So you have an access port. So it has only one wire or only one source connection. Maybe it's positive, negative, but just one cable that is powering that socket. So that is more like an access port. So you can only plug to that one source. But in a trunk cable, you can have multiple sources running through one trunk. So that is a very simple example of an access and a trunk port. So an access port belongs to or carries traffic for only one VLAN, for only one source, for only one network, for only one LAN, virtual LAN. So that is what an access port does. While a trunk port has for many VLANs. You get, it's more like a bundle, you get, for many VLANs. So this is a diagram that explains it. So if you look at here, you will find two switches. There are two switches, maybe on different parts of the same building or in different locations. Now you can have one port configured as red VLAN, another port configured as blue VLAN, another port configured as green VLAN. So each of them are access VLANs here because they are only connected to one port. Now you can also find them on the second switch. Now to ensure that this first switch communicates with this second switch, it needs a trunk link so that all the VLANs here can be routed through or can be sent through the trunk link so that they can communicate here. So red VLAN here can communicate with red VLAN. Blue VLAN can communicate with blue VLAN, even though they are geographically sparse, they are not in the same location. So, and the protocol that makes this happen is IEEE 802.1q. So, for some of you must have heard, maybe done electrical or done a little, you must have heard IEEE, which is for electrical engineers. So they have a standard 802.1q, and this standard is what enables VLANs to work. So it has VLAN tagging. So, for instance, if I want to send everybody through this trunk link, I should be able to separate red VLAN from blue VLAN. I should be able to separate green VLAN from red VLAN. Now, what allows that to happen is because each traffic is carrying a VLAN tag. So as it's going through this trunk link, it will be carrying its tag so that the trunk can know that, okay, this cable or this connection is for red VLAN. This connection is for blue VLAN. This connection is for green VLAN. Why? Because of the tag. So what allows that tag is this standard 802.1q, and is an open standard that allows for VLAN tagging for you to be able to identify VLANs. So that is for switching and virtual LANs.
This conference will now be recorded.
Okay, so we'll look at IP addressing and subnetting. So there will be videos where the mathematical parts would be taught so that you could grasp an understanding of that and you can do some exercise. Now, IP addressing. Now, I want you to know that IP addressing and subnetting is one fundamental part of networking that you cannot run away from. And if you're doing networking, you need to play around with IP addresses. You need to play around with subnets. So it is very, very key. It's at the core of networking, IP addressing and subnetting. So it's key you understand it. So IP addressing. An IP address is a numeric identifier assigned to each machine on an IP network. Just the way it is that everybody that must connect must have an identification, something that will make them unique. So an IP address is what makes each host on the network unique, is what makes them unique. IP addressing, because each person has an address and they can send, they can also receive based on the address that they have. An IP address is a software address and not a hardware address. It means it's logical. You type in that address. It is not something that is bumped in or physically assigned to the device. So some of the terminologies you should have is bits. Bits is one digit. It means either 1 or 0, zeros or 1. Byte is 8 bits. So if you have zeros and ones or binary in 8 particular 8 digits or 8 bits, then you will call that a byte. An octet is made up of 8 bits. 8 bits make an octet. 8 bits makes a byte, and octet is also, so you can say a byte is also an octet. And for some of us who remember mathematics, we said binary is 2, zeros and 1. It means base 2. Base 2 is binary. Base 10 is decimal. Base 16 is hexadecimal. So also it is here, one of the key things you will get to understand is that we work in bits of 8, in bytes, in octets. Now, in IP terminologies, you have, or you will come across network addresses, you will come across broadcast addresses. Now, network addresses are like the name of a network, just the way it is in a family that everybody has the same surname in a family. So if you come to a family, let's say Augustine's family, everybody bears that surname. The father, the mother, the children, everybody bears that surname. That is a network address. So a network address is a designation used in routing to send packets to a remote network. So if I want to send message to a particular family, I can use their surname as an identifier, and anything I send to that surname, it will get to them. Now, broadcast is also another address. Now, broadcast is an address or a name you get. Is quite different, or is quite similar to a surname, but in this regard is that it is that once you send a message to that name, everybody gets it. Everybody gets it. So just the way in WhatsApp, you said you sent a broadcast, everybody in that WhatsApp will get it because it's a broadcast message. So a broadcast address exists in every network, that if you want to send message to everybody, just send it to the broadcast, everybody will get it at the same time. So that is what a broadcast address is. Yeah. And the last, which was not even highlighted here, is a host address. A host address is like the first name of each individuals of the family. So if I want to send something to you specifically, I would use your first name and your surname. Your first name is to identify you specifically in that family. Now, network addressing. Okay, so this is where we have even the host addresses. We uniquely identifies each machines on the network. And there are 3 major classes of network. We have class A, class B, and class C. And these are the class A. They all have 4 octets, meaning they have 32 bits in total. 8 plus 8 plus 8 plus 8. 8 plus 8 is 16. 16 plus 8 is 32. 16 plus 8 is 32. Okay, so when you add this 8 times 4, it will give you 32 bits. So it's a 32 bit in total when you add all of them. So the first 8 bits is network. It signifies network for a class A. The second 8 bits is a host bit. The third bit is host bits, and the last is host bits. So this is more like the dimensioning for class A, class B, class C. As you go through the video I'm sending, which calculates or gives you how to calculate the IP addressing. So there are 3 major classes. There is class A, class B, and class C. So till date, we are using class A, class B, and class C, while class D is used for multicast. Class E is used for research. You understand what research is for university purposes, for experiments, for lab, while the multicast is a message that is sent to a group in a broader scale. So if I say in this class, I want all the mails to attend a particular function, then that is a multicast message. So let me explain. So there are three major types. I don't think I have explained this in previous classes. So I need you to pay attention. There is unicast. A unicast message is meant for one person. It's like the DM or you private chat someone on WhatsApp. It is only that person that gets the message. That is a unicast. Now you have a broadcast. A broadcast, everybody. If I say all the attendees, whether it is male, whether it is female, you are all in that category. That is a broadcast message. You have multicast. Multicast is just for a select group in that crowd. So if I say all the ladies should come to this side, it means that I am sending a multicast message, which is not meant for everybody, but a particular subset of a group. That is multicast. Then you also have what we call anycast. Anycast. Now, anycast is you connecting to a nearby device. So if you have anycast enabled, any device that is close to you or close to that device is whom that device will send it to. So that is anycast. So class A address talks about the first octet is reserved for network, while the last three octet is reserved for host. And this is the range is between 0 to 127. The class B is between 128 to 191. So any IP address that falls between these rows, like maybe 4.2.2.2 is a class A, 10.30.20.50, that is a class A. Whatever it is that falls within this role in the first octet is a class A network address. Now also for class B, the first octet, any number that falls between 128 and 191, it is a class B address. So if you say 172, 172 is between 128 and 191, then it is a class B address. Class C is between 192 to 223. So any address that falls within this range, just like 192.168, 192 falls within this range of IP address. Then class D, which is for multicast, is between 224 and 255. Then class E, which is for research or scientific purposes, is between 240 and 255. Okay, so let me explain private addressing and I'll explain IPv6. Now I want to tell you a story. Now at the onset when networks were being built, when the internet was built, they never they didn't project that the internet would be this big. So they brought in an IP addressing, and they brought in IP version 4. Now IP version 4, you're supposed to cater for a particular, if I remember, it will be 2.4 or 4.2 billion addresses. Supposed to cater for a select few. So when they brought in that IP address, it was like it will never finish because the users of the internet were universities, and government agencies. So, but when it became wide that even users like you have 5 devices, some people have 3 devices, 4 devices. They have a phone, they have a laptop and a tab. Some have a phone, or some even have 2 phones. We get a tab, maybe 2 laptops, and other devices that connect to the internet. So if we were to share 1 billion addresses, it will not reach us because one person is using 3 or 4 gadgets. So they came with the idea of private address and public address. Now they divided it. This is what they did. They said private address are addresses that are not routable on the internet. So private address are addresses you can use within your network. You can use in your office. You can use in your house. While public IP addresses are addresses that you can use on the internet. the addresses that you can use on the internet. Now, that is private IP address. So if you go to offices, you always find an IP address such as 10.10 or 10.0. When you go to any office or any environment, you always find IP addresses within this range: 10.0.0.0 to 10.255.255.255, or you have IP addresses like 172.16.0.0 to 172.31.255.255. Then this one is the most common: 192.168.1.1, maybe 2.1, 8.1. You will always find this IP address. And these IP addresses are what we call private. They are just local. They are not to be routed on the internet. So what it means is that every IP address that is not here is a public address. So if I have 9.10.10.10, it is a public IP address. If I have 11.0.0.0, it is a public IP address. If I have 172.15, it's a public IP address, or 172.32 is a public IP address. So that's one of the understandings we should have. So that's private IP addressing. So, and it's very key you understand them. Now, another concept you should also understand is what we call APIPA, automatic private IP addressing. Now, this is very common with Windows operating system. When your system cannot get an IP or cannot request for an IP or doesn't get feedback when you connect to a network, it automatically assigns itself a particular IP, 169.254.0.1 to 169.254.255.254. So these IP addresses are automatically assigned by system to itself. This is what we call APIPA. Now, when they brought about the private IP addressing and the public IP addressing, then the need for private IP addresses to be translated to public IP addresses gave birth to what we call NAT, Network Address Translation. Reason why is my private IPs cannot go to the internet, so I need a public IP. I need a public IP for me to be able to route to the internet. So they brought about NATing, and NATing was fine for good, was working well. Then after a while, they saw that the IP version 4, even with the NATing or private or public, was getting exhausted. So what they did was to go back to their labs and design a new IP addressing scheme called IP version 6. IP version 6. So it is called a next generation internet protocol. It's called a next generation internet protocol. So, and this particular IP can serve for is it 3.6 decillion. They said literally every sand in a seashore can have an IP address. So you don't need to conserve IP addresses with IP version 6 because each address is already public on the internet. You don't need to start doing that thing. So, but IP version 6 is 128 bits in size and it's divided into 3 parts: the global prefix, the subnet, and the interface ID. Now, subnetting. Now, subnetting here is very key. So I used to use this example as a great demonstrator. Now, if you have a bread, when especially for some of us that grew having siblings, you have a loaf of bread that is not sliced or is sliced, or let me use that is not sliced. You will see that you need to divide that bread into equal portions so that you can give it to the firstborn, secondborn, thirdborn, so that you can divide it equally. Now that is literally what we call subnetting. So I have an IP address allocation or an IP address range on network, and I need to divide it to subnetworks. So what you do is like taking a knife and slicing the bread into 4 portions, into 5 portions. That is what subnetting is all about. So subnetting is you breaking down or you dividing a network into sub-networks. So subnetting is breaking a network. It is subnetting. So benefits of subnetting means reduced network traffic. You don't have networks that are too big. You get optimized network performance, simplified management. Now that is subnetting. Now another concept you also need to understand is that for subnet masks. That for subnet masks. Now for subnet masks just defines the boundary. So for the subnet masking to work, every machine on the network needs to know which part of the host address will be used for the subnet address. So the subnet mask just gives a boundary as to where a network reaches. So if I'm dividing a network into 3 parts, like a loaf of bread, I need to be able to define that for this first part, whoever is taking this first portion, this is where you are stopping. For you taking the second part, this is your starting point, this is your ending point. So that is what subnet masks is all about. So, and these are default subnet masks that you can find. For class A is 255.0.0.0, class B is 255.255.0.0, and for class C it is 255.255.255.0. Okay. So the last concept we explain here, so is what we call the classless interdomain routing. Classless interdomain routing. So by default, as you can see here, there's already a standard that says class A has first as network, then host as the remaining. Class B has network, host, network, host. That is the precedence that has been set. But in classless interdomain routing means that you can break down these networks from the convention, from the default, where you can have variable or different numbers or bits of networks. So rather than having, for some of you must have heard of /24. /24 means that there are 24 ones here. /16 means there are 16 ones here because it's 8 plus 8. For this thing /8 here because there are 8 ones here. Just 1 8. This /16, 8 plus 8 is 16. This /24, 8 plus 8, 16, 16 plus 8, 24. So that's just giving you a break. So if I say /28, it means that the number of ones which signifies the network will be 28. And this is a subnetting practice question that you should do after you must have gone through the video.
This conference will now be recorded.
Yeah, so like we started yesterday, while we were working on our hands-on lab, which we were given a network to design, Ethnos Bank, and they were to have 3 branches, one in Lagos, which will be the headquarters, another in Abuja, and also another one in Port Harcourt. Now, in the Lagos HQ is where you have the backend server, the core web application, the Active Directory, the web server, the file server. They're all at the HQ. And it implies that Abuja would need to connect to Lagos to fetch resources. Port Harcourt would also need to connect to Lagos to fetch resources. So yesterday we designed the network diagram using a tool, Cisco Packet Tracer. Cisco Packet Tracer is what we're using for this simulation of this network, Ethnos Bank. So I walked you through how to use the tool. So if it is to place a node, so we can say this is Ethnos Bank. So this is Ethnos Bank. This architecture belongs to Ethnos Bank. So yesterday we were able to get our routers, connect them with the right connecting cables. So we used fiber to connect Lagos to Abuja, fiber to connect Lagos to Port Harcourt, and we use straight-through cables within the LAN for each of the branches, the one in headquarters, the one in Port Harcourt, and the one in Abuja. We also use straight-through cables in the server farm. So where do we start from? So first of all is we having an idea of the IP addressing that we have been given. So we are given a /24 here, a 10.192.168.10.0. So I will be putting that label here for IP addressing. So these things are simple. So IP 10.68.192.168.10.0/24. Okay, this is what we have here. For the LAN here, we have 11. We have 11 network. We call 192.168.11.0/24. Yes. For Port Harcourt, we have .100 network. 192.168.100.0/24. For Abuja, we have .200 network. 192.168.200.0/24. We will also have a network that is connecting Lagos to Abuja. A 1.1.1.1.0/30, 2.2.2.0/30. So we have 1.0/30. We have 2.2.2.2.0/30. Okay, so this is what we were given. So the first thing we need to do is to configure our network devices. So these are our router. One of the things you will learn in this class is how to configure a Cisco router. So this is the router. So I'll be walking you through on how to configure a Cisco router. I believe you all can see my screen. So when you enter a router, whether it's virtually in terms of in a simulated environment or in a production environment, you will always come across this when there is no configuration inside the router. Now, this mode is what we call user exec mode. If I do a question mark here, it will tell me all the commands that are launched in this mode. It tells me I can put a number, I can do connect, I can do disable, disconnect, enable, exit, log out, ping, resume. These are the commands like telnet, terminal, trace out. These are the commands I can issue here. Yeah, but this is what we call the user exec mode. Maybe let me use a notepad to first of all explain all the modes. So I'm teaching how to configure a Cisco router from the CLI. So there are three types, there are majorly three major types of configuration mode. Cisco IOS. Cisco IOS is the operating system. So whether it's a router or a switch, is the same. The first is what we call the user exec mode. And the symbol is a greater sign. The second is what we call the privilege exec mode. And the symbol is a hash sign. The third is what we call the global configuration mode. So this one, let me show you. So user exec. Now to transit Between them, enable is the command. So let me use this as an example. So when you log in, you have something like this. When you type enable, it changes to this. As you can see here. So I'm in the privilege exec mode. If I do a question mark, it tells me of the commands I can issue here. So it's just in terms of access level. Now, if I do a config terminal or config T, which is short form for configure terminal, it takes me to global configuration mode. So I will have this. So if I type config terminal, what I have would be this. As you can see here. So this is the global config mode. You have something like this. I don't know if you are with me. I want you to confirm that you are with me.
Yeah, we are with you.
Okay. So those are the three major ones. Then the fourth one is actually specific mode. So you might not see it in any documentation, but it's just specific configuration mode. Now this includes interface, router, line, so play around with them and etc. Play around with them. So, but the major three is the user exec, privilege, and the global. So now let's configure this Lagos router. So I'm in the global. Anything I want to configure, I'll do it at the global. The first thing I'll do is to change the name of the router, the host name. I want to change it from router to Lagos HQ. So I'll need to put a maybe underscore to separate it or use the same words. So if you notice, it has changed. So to change name, the command is host name. So host name Lagos HQ, it has changed. The next thing I want to configure is what we call enable password or enable secret. Now the difference between enable password and enable secret is that the enable secret will encrypt the password, while enable password will make the password in plain text. So let's give an example. Enable password Cisco. So if I want to view the configuration file, let me go back to privilege exec. End is a command that will take you back to privilege exec wherever you are. So if I do show run it's more like the running configuration on the device. There are two major configuration files on the device. There is running config and the startup. Startup is what it will use to boot up the system, while running config is what is running in the RAM, running on the go, running live. So it means that if I want to save a config, I am going to copy whatever it is in the running config and paste it in the startup config or overwrite it in the startup config, so that whatever it is I'm running, I have configured in the running config can begin to work in the startup. So I just wanted showing that the enable password will show you password in plain text. So if you have a look, say enable password, anybody that sees your configuration will know your password. So, but if I do enable secret, Cisco. Okay, I need to do it on the global config mode because I'm configuring. Say config T is short for configure terminal. So if I try that command, enable secret Cisco. Okay, he said enable secret you have chosen is the same as enable, but this is not recommended. Enter another one. So let me use Cisco 123 as my enable secret. So if I do show run, if I do a do show run, the do command will allow me to use a command anywhere as long as I know the syntax. So do show run shows enable secret, then this is encrypted in MD5. These things are very simple. So another thing I will configure, so I have configured host name. So what are the basic configuration I am doing? The first, I configured host name, and the command I used is host name, then the name of the device, all in the global config mode. Second, I configure enable password or enable secret. And the command I use, enable secret Cisco. Cisco is the password. The third I'm doing now is what we call line console. So because I'm logging in a console like this, I need to give a password. Line console. What I just typed in full text is line console 0. 0 just signifies the console I am logging into. Then I'll put a password, Cisco. I'll put this command login. This command login is to make the password work. Okay, so for console password and login. This is a command I used. Line console 0 password Cisco login. So these are the commands I'm using. These things are not rocket science, they are very simple. So to configure your console password, the next thing we'll configure is VTY. VTY is terminal access. Terminal access password and login. So this is what I'll do. I'll do line VTY 0 to 4. For a router has 5 slots or 5 users that can log in at a time. That's the maximum. So I'm saying from the very first user to the last user, whatever it is I configure, let it apply to them. So 0 to 4, I'll put a password, Cisco, I'll log in, then so line VTY 0 to 4, password, Cisco, login. Okay, I think I got by. So these are the basic. So if I do end, it will take me back. So if I want to save, there are 2 ways to save it. I'll do copy running config to startup config. Remember when I explained running config and startup config? Running config is where whatever it is you do live is saved. So, but the disadvantage of having everything in a running config is that once there's a power off or cut, everything disappears. But startup config is what you have that even when there's a power off, it will still start up with. So I'm copying the running config into the startup, and it's asking me startup config, yes. So I've saved whatever it is I have configured on this device. So another command is WR. WR is a shortcut, right? So 5, save configurations. Copy running config. To startup config. Or we use WR. So with this, I have configured the Lagos router. So I'll also do the same for Abuja router, Port Harcourt router, the switches also. So we'll give room for questions now. So give room, we'll stop today, then next week we'll continue. So what I'm expecting from you for next week is, I'm expecting that you must have drawn this diagram after I've sent the video. I'm also expecting that you must have gone through the IP addressing videos I will send, so as to try out some exercises. Then we'll continue configuring on each of these particular devices, the routers and the switches.